And now it's time for chapter 6. So this is going to be a little bit different than what we've been doing in the past. We're going to be using a standard normal distribution. So that means a bell-shaped curve. And with this normal distribution, the mean goes in the middle. Right there in the middle, and that would be the mu, the mean for the whole population. Now in this particular section, we're going to take the simplest case where the mean is equal to 0 and the standard deviation is 1. And that is what's called the standard normal distribution. So normal means that it's this bell-shaped curve. And then standard is when you have the mean equal to 0, standard deviation equal to 1. So we're going to be using table A2 to find probabilities. Where's table A2? Well, if you look at the Canvas homepage, it can be found in a couple of places. The fastest, easiest would be right there under modules. It's called the formula card. Also, if you're watching this video from the modules, then it was the button right above the one for this section 6.1. Okay, now that you've got that, it looks like this. So how do you actually use this? Well, here we go. So find the probability that a z-value is under 1.51. Now because the mean is equal to 0, that means that we don't have to do the z formula. And since the standard deviation is 1 also, we don't have to do the z formula in this section. It's just given to you. Under would mean less than or equal to, so that's this red shaded part to the left of 1.51. So when doing these, it's good to sketch a little picture to figure out which part it's talking about. So here is table A2. And the way that this table works is you look at the number and the first decimal point. So this is a 1.5. And on the left side, you look for 1.5. That would be right here. And then either just with your finger follow along, but you go, here's the row for 1.5. Then the last decimal place is a 1, which is what this part right here is saying. So we're going to use this column and this row. So that represents 1.5, 1 for the z-score. And then right under where those two yellow lines cross, it's a 0.9345. Now keep in mind that when you look at this picture, all of these answers in here are for this left shaded side. That happens to be exactly what we were looking for. So that means that 0.9345 is that shaded side, and the first one is done. Okay, on to example number 2. Find the probability that a z-score is over 2.10. So draw a little picture. Over would mean to the right, so it's this small area right here. So we should end up with a fairly small answer when we're done. Then get table A2. Also notice that so far the z-values are positive, and I'm using this one that says the positive z-scores. Then we need to look up a 2.10. So that would be 2.10 is right here in yellow. And because the last decimal place is a 0, that means I'm going to be using this one right here, which is 9821, so 0.9821. Now that means, because this gives you the left side, that means that the left side is 0.9821. So the right side would be the complement, so that would be 1 minus 0.9821, which leaves 0.0179. And that is the right side, and that one is done. What about number 3? What about if it's between two values, like between -2 and +2? So I shade the area. Over here is z equals -2, and over here z equals +2, and then shade in between. So get out the old positive z-score because we're going to have to look up a 2, but we're also going to have to look up a -2. So if you look at the other side of that, or depending on how it's folded, but very close to the positive z-score is the negative z-score table. Okay, over here on the positive one, look up the positive 2.0, and that's going to be 0.9772. Then look at this one, and right here is z equals a negative 2, and that's going to be a 0.0228. Then if you want the area between them, you subtract them. It needs to be the big one minus the small one. So it'll be a 0.9772, then subtract the 0.0228. And then on this one, looks like I decided to round to 3 decimals, so the area in between is a 0.954. Next up, find the probability that z is between negative 2.78 and a 0. So it's this shaded area right here. Now, if it went from 0 all the way to the left, that would be 50% of the graph, where the answer would be 0.5. Now, this shading actually does not include this tiny little tail right here, so the answer in here should be close to a 0.5. Let's see. So get the table, the one that says the negative z-score, and then look up negative 2.7. Here's negative 2.7. And then go over to the 8 for the last decimal place, and then that is a 0.0027. So this graph, when you're looking at the negative one, the negative z-scores, it's going to tell you the far end, which is actually called the tail end. And this tail end right here is going to be 0.0027. So in order to find out what's in between the two, we would subtract. So this would be half of the graph if it included the whole thing, or 0.5. If you subtract off that little tail part, it's going to leave what's in the middle. So what's in the middle is a 0.4973. All right. Now for the even more fun part, work backwards. So with these problems, you're given a z-score, and then you find a probability, or a percent. This would be 49.73% is what the shaded area represents. So now we're going to work backwards, and we're going to find the z-score. So if you're given a percent, can you find the z-score? Yes, you can. So find the z-score needed to get in the top 10% of scores. So again, it's helpful to draw a picture. So I started with this 0.10 right here. That's the top 10%. And then there's a line right here that divides the top 10% from the other 90%. And the question is asking, where is this line? What does z equal? So you've got the table. Keep in mind that this part right here, all of these answers in here pertain to the left side. So for the left side, I've got a 0.90. Now since 0.90 is a probability, then what I need to do is look through this table for the closest that's closest to 0.90. So this one is a 0.8980, but this one's even closer at 0.8997, and then this one is 90.15% or 0.905. Excuse me, 0.9015. Now, when you're looking for these and you're trying to find whatever's closest, it doesn't have to go over it or under it, just whatever's the closest. So it turns out that that 0.8997, that's the closest. Now here's how you work backwards. So then you have to find out what the z-score was. So you look over to the left. That means the z-score started with 1.2. Then look to the top, and that means the z-score has to end with an 8 as its last decimal. So that means that the z-score equals a 1.28. Well, that was so fun. Let's do one more. Find the z-score for P32. Do you remember chapter 2? Do you remember that there was a chapter 2? Yeah, there was. Anyway, P32 stands for the 32nd percentile. So if you started with the very lowest score, and then you go up until you found 32% of the data, that's what it's asking for. So over here somewhere is the lowest score, then go up and up and up until this is 32% of the data. Now in the middle, that's where z equals 0. So that means to the left, z is a negative. So I should be using the negative z-score table. And this is the shaded part, so that's represented right here by this 0.32. And then you start searching through the table for the closest to 0.32. And I found a 3192, and it turns out that 3192 is the closest. So then use the table backwards, look over to the left, and that means the z-score equals a negative 0.4 something. And then look to the top, and then that means that the last decimal place is a 7. So it turns out that z equals negative 0.47. And then in the next section, we're going to be doing basically the same thing, but with the mean equal to something other than 0 and the standard deviation equal to something other than 1. But otherwise, the work is going to be very similar.